Hello everyone. My name is Sachin G. Kumar. I have completed MA English and currently I am pursuing Master Certificate program in Artificial Intelligence at Sri Shankaracharya Computer Center in Pragyan AI and DSS School. Okay. Here, today I am dividing my session into two parts. The first part includes case study topic, its introduction, what is machine learning, regression, and classification models, and its algorithms, and model performances, both regression and classifications. At last, conclusion, and the second part discussing about case study step-by-step code explanation and its other basic points. This is my case study topic, car insurance modeling. Here I am using both regression and classification models to create a holistic model. The introduction. Car insurance modeling is the application of statistical and machine learning techniques to analyze and predict various aspects of car insurance, such as claim frequency, claim severity, and overall risk assessments. These predictions are essential for insurers to. These are the points. First one, price policies effectively. Second one, manage risks. Third one, optimize business operations. The dataset used for car insurance modeling case study provides detailed information on factors that influence car insurance claims. It includes a variety of features that describe customer demographics, vehicle characteristics, claim history, and geographic details. This dataset is well suited for both regression and classification tasks, such as predicting the total claim amount or identifying the likelihood of a claim. These are the objectives of this dataset. And then this case study showcases how business can leverage predictive models to stay ahead in the competitive insurance industry. This dataset includes the following important features. First one, age of the driver. Second one, car age. Third one, region. Fourth one, number of claims. And fifth one, additional attributes, that is driver's gender or mental status, and vehicle type or engine size if involved. This is the dataset summary. First and total records. Second, missing values checking. Third one, pre-processing steps, that is scaling, handling outliers, correlation check, and etc. And then we discuss what is machine learning, regression, and classification separately. First one, regression. Regression models are used when the target variable is continuous. They predict a numerical value based on input features. These are key characteristics of regression models. First one, output is a real value. Second one, evaluate using matrices like mean squared error, MSE, or mean absolute error, that is MAE, and R score, that is R2 score. These are the common regression algorithms we use in the regression model case studies. First one, linear regression. Second one, polynomial regression. Third one, rigid analysis regression. Fourth one, decision tree regression. Fifth one, random forest regression. Sixth one, support vector regression, that is SVR. Seventh one, neural networks, and etc. Next, we discuss what is classification models. Classification models are used when the target variable is categorical. They predict a class or category based on input features. These are the key characteristics of classification models. First one, output is a discrete value. These are the examples. And the second, evaluated using matrices like accuracy. These are the common classification algorithms we use in classification case studies. First one, logistic regression. Second one, decision tree classifier. Third one, random forest classifiers. Fourth one, support vector machine, that is SVM. Fifth one, nearest neighbors, that is KNN. Sixth one, navy bias. And next, neural networks. These are list of models used in car insurance modeling case study. First one, regression models. We use linear regression, random forest regressor, decision tree regressor, gradient evolution regressor, k nearest neighbors, that is KN, and support vector regressor, that is SVR. The classification models, we use logistic regression and a forest classifier, gradient evolution classifier. So these are the model performances, both regression and classification models in this case study. And the advantages of car insurance modeling is the first one, improved risk management, and second one, optimized pricing strategies, and third one, enhanced customer segmentation for the data-driven decision making. Conclusion. Car insurance modeling is a virtual tool for the insurance industry, enabling companies to make data-driven decisions that improve operational efficiency, reduce risk, and optimize pricing strategies. By analyzing historical claims data and leveraging advanced statistical and machine learning models, insurers can predict claim frequencies and severities with greater accuracy. This not only enhances risk management but also supports better customer segmentation and fraud detection. The insights gained from such modeling empower insurers to remain competitive in a dynamic market while delivering value to their customers. Overall, car insurance modeling serves as a cornerstone for achieving strategic business goals through the effective use of data. Next, we discuss about the regression classification model case studies. This is my topic, car insurance modeling. This is a data set use insurance claims.csv. What is car insurance modeling? Its introduction we already discussed. Firstly, we import the libraries using pandas, NumPy, Matplotlib, Seaborn, sklearn, something like this. And then we load the dataset using these pd.read_csv codes and check, and we print the first 5 rows of this dataset using this header function. And then we check the information using this .info function. Then we check the missing values using these codes and print the mean, median, standard deviation, Q1, Q2, Q3, and maximum of this dataset using this .describe of function. After finding these information and missing values, we can understand that if there is no missing values exist. Here there is no missing value exists, but finding missing values using these value count and Unicode functions to find any non-values exist. We check in non-values using these functions. Here there is no non-values exist. And then we print the columns names using this column function. Next, using label encoder. Here we using this label encoder, we can convert or transform the object into integers. Here the region column is an object. Then using this label encoder to convert the object into integers. So first of all, we import the label encoder, and then we initialize the label encoder and apply the label encoder to the region columns, and then print the 5 rows of samples. And next step, that is EDA, explorative data analysis. Here we create a correlation heat map using these codes. Here, the first block of the code generates a heat map to visualize the correlation between numerical features in the insurance DF data frame. And the SNS.heatmap function from the Seaborn library is used with the not equal to true argument to display the correlation coefficients in the heat map. And C map equal to Coolvan for a diverging color palette. A correlation heat map helps identify relationship between variables indicating how strongly they are related in positive or negative correlations. The heat map shows the relationship between numerical variables in the dataset with values ranging from 1 -1 to 1. The positive correlation are indicating by red shades, and negative correlations by blue shades, and the neutral relationship are light colored. The, the strong correlations, example 0.83 between numbers of claims and claims class. Here suggests a significant relationship between those variables. Next, we create a histoplot using these codes. Distribution of the target variables. The first block of visualization, the distribution of the target variable number of claims, and the SNS.histoplot function creates a histogram with the 10 pins overlaid with a kernel density estimate that is KDE, for smoother visualization of the data distribution. The plot provides insight into the range, frequency, and distribution shape of a number of claims variable, helping assess if it is skewed, normal, or multimodal. The histogram shows the distribution of the number of claims variables. Most customers have 0 or 1 claim, with the frequency decreasing as the number of claims increases. The data is right skewed, indicating that higher claim counts are less common. The KDE curve overlays the histogram for a smoother representation of the distribution. And next, we create a chord plot using these codes, region-wise distribution. This code creates a count plot to visualize the number of drivers in each region from the insurance.df dataset. The x equal to region argument specifies that the x-axis represents the regions, while the y-axis shows the count of drivers. The plot provides insight into the distribution of drivers across different regions. The plot shows that the count of drivers in each region, that is 0, 1, 2 regions, 0 and 1 have slightly more drivers compared to region 2. Yeah. But the distribution is fairly balanced across all regions. Next, that is data pre-processing. Here, in this code converts the categorical columns region into binary dummy variables, dropping the first category to avoid redundancy, that is dummy variable trap. Each new column represents a region with value 0 to 1, indicating the presence of that category. And then future target splitting. Here, the X is future and Y is target. And this code splits the dataset into features and the target variables. The X contains all columns from insurance DF except number of claims, and these are the input features used for predictions. And the Y contains only the number of claims column, which is the target variable to predict. And then we use the standard scaler using these codes. Here, this code standardizes the future data of X using the standard scaler. The standard scaler is used to scale the data so that each feature has a mean of 0 and a standard deviation of 1. Here, the fit transform of X is which fit calculates the mean and standard deviation for each feature in X, and transform applies the scaling to standardize the data. Here, the X scaled is the resulting standardized version of X, where each feature is normalized to have 0 mean and unit variance. And then when we use these codes to split the train and test, and then we check the shape of this train test, this shape, and then that is use regression models. Firstly, use linear regression. Here we use these codes. Firstly, we initialize a linear regression model, and then we train the model and predict on the test sets test, and then we evaluate the model using these MSC score and RQ score and print the results. This is a linear regression model results, and then we use random forest regressor. This is a scores. And next decision tree regressor, and fourth one gradient Bourdieu regressor. This is a MSC score and RQ score. And next that is KNN, neighbors regressor. And at last, support vector regressor, that is SVR. Here we use using these codes to compare the all models' performance in one place. And this is some models we use. This is a scores, MSC R score. And then we display the results. And then we visualize the performance and separately using MSC score and R score. This is performance based on MSC score. This is the model performance based on the R scores here. And then we print the scores in the ascending order wise using these scores. Based on the evaluation matrices provided, R score and MSC, the best model is the one with highest R score, that is closer to 1, and the lowest mean score, that is error MSC, lower is better. This is our ranking. Here, the linear regression is the best performing model based on the R score and the MSC score. The second one, that is gradient Bourdieu regressor. Third for this. And next, we use the classification models. Here, we create a binary classification target. Here, this code creates a new binary classification target column called claim class and apply the lambda x1 if 1 greater than 0 L0 assigns a value of 1 if number of claims is greater than 0, indicating the customer has made claims. And then we assign a value of 0 if number of claims is 0, indicating no claims made. Then we split the future and target and train the split. Here the X is futures or columns in insurance TF except number of claims and claims class. And the Y target, the claim class column, which contains a value to be predicted. This is a common steps in preparing data for machine learning models. This is train the split and future and target. And then we use classification models. Firstly, we use logistic regression, and secondly, random forest classifier. Thirdly, gradient Bourdieu classifier. In one course, this is a 3 models scores: the accuracy score, precision, recall, F1 score, and ROC scores. And we visualize the performance using these. This is a bar plot we use to visualize the performance. Here, the blue one is logistic regression, the orange one is random forest, and the green one is gradient Bourdieu, based on the accuracy score, precision score, recall, F1 score, and ROC usage. Here, the X is scores and Y is matrices, and we sort the scores using the ascending order wise. Here, the logistical regression is the best performing model overall because it is the highest accuracy, precision is highest, and ROC is highest. Here, accuracy is highest, precision is highest, based on 3 models, and ROC is the highest. And the second one is random forest, strong conductor for the recall based task because it is a recall is highest. 52. Sorry, 60, F1 score 55, and the gradient Bourdieu performs the worst across all matrices because this is the lowest value in all categories. And then the conclusion. In this analysis of predictive insurance claims, both the regression and classification models were explored to understand and predict the number of claims and the likelihood of a claim being made by a driver. The models were evaluated based on performance matrices, and the key findings are summarized below. Based on the regression task, and the classification task. We are using this prediction task to predict a number of claims. It's using a regression and a forest regression. And next, classification task predicting claim likelihood. Dependent classification model, logistic regression, and a forest classifier, gradient boosting, etc. This analysis has provided valuable insight into how different models can be leveraged for insurance claims prediction and classification tasks, and suggest avenues for improvement into both models' choice and optimization. Here, I believe everyone will understand at least a little. If you want to know more about this, this is my GitHub link. This is my library link. And similar case studies. It also has other regression and classification model case studies and its YouTube explanation videos. Thank you.
Ashwin,
Yes, sir.
what is the performance? What is accuracy? Can you go to that code, that location? How was that? What is the performance? Go to the performance chart in the code.
First button.
No, performance. Where is the performance? So you go up. See what is the value? Come down. Uh, what is accuracy? You are getting 50%, correct?
Yes, sir.
So I see. Now you need to think about what needs to be done to make accuracy at least 85% and above. Okay, because accuracy 50% means like it doesn't mean anything actually. Like 50 means like if, for example, if I ask you whether in a cricket match, let us say that like RCB and Chennai Super King is playing. If I ask you who will win, then if you say 50-50%, then did you say anything? Anybody can say 50-50, correct?
Yes, sir.
So if I have to bet on something, means like at least 85% accuracy, I should be saying whether RCB will win or Chennai Super King will win. So accuracy, you try think about how should we make the accuracy 85. Okay.
Okay. Okay, sir.
Anybody can suggest, like, so you can post that question, code and ask. So what I will do now, like we will create in the same group. You post the code and ask the suggestions. So anybody who wants to give a suggestion to him, you can give a suggestion how to improve. Okay. Next,
Okay,
what
sir.
you do, you take some time to make it that you model with at least 80-85% above accuracy. Okay.
Okay, sir. Okay, sir.
Okay. So thank you. So it was good. So next one.